Merhaba arkadaşlar. We will continue the discussion on exception handling. I will do a couple of examples, and then also we will finish up the last part of the GUI components, which we didn't cover was split pane. So we will go over that example, and then after that we are going to start recursion today. And recursion is also one of the important topics of this part. So again, there will be definitely a question in the final related to recursion. So please follow and understand how it operates and what are the things that you need to be careful about. So if you recall, exceptions are the cases where we would like our application to respond to certain normal or abnormal behaviors of the application, such as runtime problems that you may have, such as the exceptions, runtime exceptions that are caused by division by zero or not able to find a file or things like those were the exceptions, if you recall. And again, I will come back to that after I finish this split panes example, which was the last GUI example of this chapter. So we will last time what we saw was the combo boxes. Remember, you have a list of items that you can choose from, and that was the combo box. And then we have the scroll panes, which gives a smaller area for bigger objects to select and scroll through within the given area. And in the split panes, however, we have a component which basically gives you an option of having a divided pane, such as from left divided by a bar in between left and right components in a horizontal fashion, or as this one in a vertical fashion, such as top and bottom components. So you can choose what kind of division you would like to have, a vertical or a horizontal division. So divider bar could be selected to be such that it moves in one click and so on. So you can have different properties of the divider bar to set and use for different purposes. So as I said earlier, you have the horizontal split or vertical split constants, which are set for your split pane. And then also you could have a nested structure where you have more than one layer in between the split pane, such that, for example, let's say you have a split pane and then you divide it into two halves, left and right, and then you have another split pane inside the right part to divide it into two halves, such as top and bottom, and then you have another split pane here, so that you have a different nice hierarchy structure for your implementation. Again, this depends on what kind of application you would like to implement and run in your GUI. So you will need to set up your environment using those features enabled using the split panes. You can have a continuously adjusted environment for inside the split pane, or you could just leave it you could leave it as it is until the bars stops moving, or you adjust it according to the movement momentarily. So basically you can set different things, and again, as I said earlier, split panes can be nested, so you can have a nested structure in your split pane, such that, for example, you have a picture shown here, and then you have a list here which has sublists, for example, and then you choose from either sublist, and then according to that, your image that you have on the left part of this divider bar is updating itself, and so on and so forth. So you can have different options enabled here and implement it in a nicer way for your own implementation. And then lists is also another option that you could use. In the example, this pick image example, we will see both the JList and then also the split pane as a single application. And then this is basically a list of items which you can choose from. So it lists you the certain options that are given to it, and then according to that you can perform again an action and choose a file, show something on the screen. So it basically provides a list of objects or things that you can choose from. So let's see this example and it will be more clear. So if you see list control, list panel, and then we have the pick image.java file. So if you look into this example, basically you have the list panel which extends JPanel, and then you have the list panel which extends JPanel, and then we have the JList and JLabel. JList is the list that we are going to use for listing these images, image names on the screen. So you have the string array which is composed of circuit.gif as a string, and then you have duke.gif and file names given as strings and as a whole a string array, right? And then you're creating the new list by giving these string array as an argument so that it creates you a list of strings as a result. And as you see, add list selection listener. So each item of this list will be, one of these strings. Or you could alternatively add these list items one by one using the add item method call. So you can just add these onto the JList. And once you select one of the options from this list, what's going to happen is that it is going to kick in this list listener object and activate it such that it will perform a certain action based on that, right? So this is basically used for listening to that list. If a user clicks one of those JList options, it is going to fire a certain method, in which case this is list listener objects method. And if you look into this, I will come to this shortly. List selection model, single selection. You can set this to single interval selection or multiple interval selection, and I will explain what they mean shortly. And you have the list added to the panel, so you have the list on this list panel. And if you look into the list listener, which was the object that I was referring to whenever you click one of the options in the list, it basically implements the list selection listener, which is an interface which you're implementing, and it only has a value change method. Whenever you click, the value change method will be activated, and within this, it is going to update a certain setting. In this case, if list is selection empty, if nothing is being selected, it is going to basically set the label set icon null. So it's going to set a label to a null object. In this case, it's a picture, an image label. However, if it is one of the options that is being selected, if something is being selected, string file name, so you're going to get the corresponding file name but by list.getSelectedValue. So this is going to return you, if the user clicks one of the things among the list, whatever that string is, it's going to return you that. Let me execute this so that you see what I'm talking about. It will be more clear. And let me execute it. So if you look into this, basically what you see is that, so this is the list image that I was referring to, right? So this is the list panel. So you have all these strings printed on the screen as list elements, list items. And then whenever I click, it basically selects this, and then the corresponding images shown on the screen. So whenever there is a selection from this list, which brings you to the else part, right? In that case, list get selected value. This is going to return you a string value. In this case, it is going to basically return you the first item, which is circuit.gif, right? So this is going to then create an image using this string, the file name. So it is going to get the image that's related to the circuit.gif, and you will set this label on the right hand side to this image. Okay, so basically whenever I click this, it will again fire that same method, and then it's going to generate the duke.gif from this file name for this file name, and then use this file name to generate the corresponding label on the right hand side. So if we go into the pick image, if you look into here, basically it is composed of a J frame, so that's the title of the frame, pick image, and then it has the image label created, and then image panel, which is also created. On the image panel, what you do is you add the image label, the right hand side, and also on the image panel, set background color is set to white. However, the image list is also created here. So for the left hand side panel, you create the image list, and by using this two elements, you create the split pane, image list and then the image panel, the left hand side and the right hand side. And as you see, it creates a J split pane horizontal split. So it basically creates an horizontal split between these two panels, right? So it creates the image list and then the image panel. Then set one touch expandable. So whenever you click onto the middle bar, the divider bar on the middle, it will select, one touch click. This one is enabled so that it is going to basically expand and, enlarge. So this is basically setting set one touch expandable true by enabling that click to be enabled. And then it basically at the end adds this split pane onto the frame and sets the visibility to true and gets the size and so on and so forth. So the only thing is that you are basically adding the two components, the image list on the left hand side, that is we created the image list, and then the list panel, right? So this was the list panel which we created by listPanel.java, which is of type JPanel. And then on the right hand side you have the image panel, which basically has the label with the picture on that label. So according to the clicks that you have on the left hand side, it updates the corresponding image on the right hand side. Okay, so basically you select this, so it selects the corresponding image from the files that are available in the same directory, obviously. And one thing to note here is that you're not able to select more than one image at the same time or more than one item at the same time from this list. This is due to the fact that you set this, where's that? List selection model single selection. So you can modify this to select multiple interval selection. Multiple interval selection, so that this way you're going to basically enable selecting multiple. I think it's done. Selecting multiple items from the list, you're going to enable this by doing that. So I will be able to do that by using the control key so that I select more items, and also using the shift, for example, you can select multiple items at once as an interval. So it provides you multiple interval. However, in this case, having multiple interval will not help us, right? Because there's only one image that we are displaying, which is going to be the first image that you clicked in the list, and that's going to enable the picture on the right hand side. So having multiple interval is not going to do any good to you in this case, but if you need to use such features, you can do so. Okay? Any question? So basically this is related to the split pane, which you can move with the divider bar, and also the list, the JList object, which is available for your usage in your also projects. Again, these are helpful things that you can utilize in your implementations. And if you look into this, you have the single selection, single interval selection, so you can set only one interval, and then multiple interval selection, so you can have multiple intervals of items selected from the JList component. Okay? So you can modify that feature to set it to the corresponding values. And again, these are the things that we have seen so far. Why do we need the exceptions, the exception messages? How does the exceptions propagate? And then also, how does the try, catch, and finally statements work? how do you throw an exception that is created by yourself. So you create an exception and you can throw it by the throw statement. And also you can use the throw statement to handle the checked exception. What was the difference between checked and an unchecked exception? So in the, as your friend said, you don't need to catch the unchecked exceptions, such as runtime exceptions, or errors that might be present in your code. However, for checked exceptions, you have to catch those. The remaining exceptions, such as IO exception, you have to either catch them or indicate that it is going to be possible that you can have such an exception by indicating in the class header. How are you going to indicate that? Public class, let's say test, throws, and then you will say such as IO exception. So you will indicate that although I'm not catching this exception, I know that this might happen. So I'm indicating it may throw an IO exception. So get prepared for that, and so that your compiler will not complain about this and you will not get any compiler errors. If you do not include this, you will get a compiler error, or if you do not include a try catch statement, you will get the compiler error. So let me go over a couple of examples that might be helpful to understand things more better. So if you look into this example, what is going to be generated as an output from this example? So you see that public class divide exception, and then public static void main string args, and you have division 100 by 4, and then division 100 by 0, system out print line exit main. And then if you go into the division method, basically it takes the two integers as argument in total sum in total number, and then system out print line computing division, then it says int average equals total sum divided by total number, and then it prints again another message, average is equal to blah blah result. So what is going to be generated as an output of this application if I run this application? So for the first division, it is going to start with system out print line computing division, and then it is going to compute the average by dividing 100 with 25, which is by 4, which is going to get you 25, and then it will write average is 25, and then exit, no problems. And then division 100 0, it's going to basically again write computing division, and then this is going to generate you a exception, right? So you are going to generate an exception which is going to print this line, or no? You're not going to see this line at all, right? And then it will just exit this with an exception, and then here what's going to happen? Are you going to print this or not? You're not going to print this line as well, because since there was an exception, program will terminate with exception message indicating the cause of the exception and where it occurred and the details of the exception. As you see, computing division for the first one, average 25, and then second one starts computing division, and then you get the Java lang arithmetic exception divide by 0, the exception message, and you see that divide exception dot, so it gives you where it happened. It is the name of the class, and then you have the method name, and it is at line 11, and then this is propagated up to the main method, divide exception dot main, which is actually the method call divide exception dot java. If you see, this is the line for the method call, and then this is line for the actual execution of the statement. So line 11 indicates this, line 5 indicates that. So if you look into this second example, as you see, you have public class divide exception 2, and then there's the main method, and it has the second line int result division 100 0 as the line 2, and then it prints the result at the end. And if you look into this part, the division method is now modified, still with the two same arguments. And however, in this case, it has the quotient variable, which is initially set to -1, and system out print line computing division. You have the try quotient, again, try to get the quotient for the division. Catch exception E and exception, it's going to get the message for the exception, which indicates what is the cause of the exception. So the get message will give you, whenever this exception is caught, whatever the message is going to be for that specific exception will be printed here. And once this exception is caught, what's going to happen, how is this going to behave for the given line here, 100 by 0. So it will basically try this, and then we'll see that there's an exception, and the exception will be caught by this exception. You can catch any exception with given exception E, because it is the, ancestor of all the exceptions. So you don't need to give the specific instance of the exception. If you give exception, that is sufficient to catch any exception that might be present in your application. For example, if I had something like this, so let's say I modified this code such that I will come back to there shortly. So this was the original thing. I have catch exception E, or let's say E1, and then you have the system out, and I have whatever is there, exception. I'm not writing the rest. And then also you have another catch statement here. Let's say I have catch arithmetic exception E2. And then I say here, I have the brackets, system out print line, and then I say arithmetic exception. And the rest is again with the message. So what is going to happen as opposed to this one? So I added an additional catch statement here to indicate that, hey, I'm catching exception E1, and then I'm catching arithmetic exception E2. So basically what's going to happen is that, as your friend said, this is a more general exception. It will first try this exception. And then once it sees that it is an exception it can take, it's an exception that is able to, satisfy this exception conditions, it is going to catch, the exception will be caught by this exception handler. So it will never go into this exception at all. So basically what you have to consider is that you can have exceptions listed, and then at the end, if you include this as the last item, anything that doesn't belong into the above catch statements will come to this exception. So usually you don't want to do it in that order, but rather this order, because otherwise it will always be caught by this exception handler rather than going into any other exception handler. Okay. So since this is a more general exception handler, any exception will be caught by this statement. Okay? You can, so having this specific instance is that you may, respond to a specific case specifically. So for example, if there's an arithmetic exception, you will respond to it according to the things that are present for that arithmetic expression. For example, you may have another catch statement indicating, let's say, index out of bounds or string index out of bounds exception that is going to specifically deal with the strings index out of bounds problem. And then for the remaining things, you may just want to print out the exception, and that's it. Okay? So if you want to, have a general exception catch statement, you would like to have it at the end rather than at the beginning. So here in this case, however, it's going to catch any exception, including the arithmetic exception which occurred here. And in this case, it's going to basically print out the exception message, right? And then it is going to execute which part after this? It will execute the finally. No matter what, you will execute finally. So if quotient is not equal to -1, it is going to print out the result. That means you were, in the try statement and you successfully finished the try statement. Otherwise, it will go into this part. Finally block executes, exception occurred, and then just returns the -1 as a result. Obviously, you can say that, hey, what happens if I divide 5 by -5, right? Which generates a -1 result. In that case, this is not 100% correctly working for that specific cases. Okay. So if you divide, for example, if you call this method by division 5 minus 5, right? What's going to happen? The result is going to be, the quotient is going to be -1. And then when you come here, quotient will be -1 since it will come to the else part. And in which case it will say exception occurred, although there wasn't any exception, right? So this is not fully correct code that's written here. Okay? So this is what is going to happen with the exception message. If you have the get message, it's going to basically divide by 0. Message will be printed as the exception, and then exception occurred will be written and result will be -1. So this was, or this is the quiz, or no? No, this was a quiz that is asked to the other section. So I'm just doing it for your own benefit. So if you look into this, so if you try to execute this, how is this going to work? So as you see, there is the demo object which is created for the test class. So this is the test class which has various methods. And then you start system out print line 1. So the question was, what will be the output of this program? So basically what's going to happen, you will start with test demo, you create the demo object, and then system out print line 1. So basically you will write 1 here. And then you will call demo.a. So A will start after this, right? So A will start at this point. And then when you come into public void A, system out print line 3, right? So it's going to print 3 since A has been called. And then you will have the try block, and then it's going to call B. So I will just go into B now. A starts, B starts. And then I will go into B. Where's B? B is going to write system out print line 5, right? So it will print 5 on the screen, and then it will call C. And when you call C, it is basically having int numerator 10, denominator 0, and then it is going to print 7, right? And then it is going to say int result numerator denominator division. So this is going to generate an exception, which is going to be, which is going to prevent anything that's printed below in this method, which is, going to ignore this system out print line 8. So you will not print this. And then go to one above method, which was the B method. So B method called C here. Is there any try catch statement that is going to catch that exception? No. So you're not going to be able to catch it here. So you will go up one more level, in which case you will go wherever B was called. So you're going to throw this exception to the caller of yourself. In this case, it's going to go here. So this is where the B was called. And then as you see, it's in a try catch statement, and this can be catched by arithmetic exception, which is exactly matching. And then you're going to go into this catch part. So it's going to basically print the exception messages message is blah blah divide by 0, right? So it's going to basically print this line, and then after that it is going to print what? How many say 6? No 6? How many say 8? It's basically done with the rest of the methods. Once it's done with the catch here, it is going to continue with the next statement in line, which is going to basically print 4 after this exception message. And then you're going to be done with this method call, which was A, and then you will come to this finish of the A, and you will start printing this on the screen. So it's going to, after that, it's going to print 2 on the screen, and this will be the output of the application. Okay? So this is basically the propagation of the exceptions throughout the method calls. If you have a catch statement, it will thrown until all the way to the top, wherever you can catch it. If you cannot catch it, basically the program will terminate abnormally, printing the exception message as a result at the end on the screen. Any question? Okay, there might be a question, something similar to this one on the exam. So, if you don't understand it, go over it again until, you see what the actual idea is. So, as you see, this was the answer for the question. You wouldn't be asked to write it exactly in the same way the Java will provide, but so you don't need to really know how this is going to be written, each individual messages, what they type, and you don't need to know that. Nobody's going to care the rest of the line from here, from this point on. Okay, so we're going to start on chapter 11, which is basically going to deal with recursion. So recursion is an important topic in this course also, because it is one of the interesting and nice and elegant ways of implementing different algorithms and implementations. And anybody who says I'm a computer engineer definitely needs to know this, and who wants to say that I know how to program also needs to know how to program recursively. So if somebody tells you write this code in a recursive manner, you should understand what it means, and you will be able to implement it if it is possible to implement it. So as I said earlier, it's a fundamental technique which provides nice solutions, as we will see with the GUI components that we are going to implement. They really provide nice features, and in this chapter we are going to see how to think in recursive manner, and then how you can write programs, and also what are the drawbacks of recursion. So it's not always free to have that elegant, nice solutions, and it has its own problems. And we will see recursion examples both in GUI and then also in regular programming assignment type of things. So first we will start with the recursion definition. So a recursive definition is the one which calls itself to implement an algorithm. So let's say you have a method that uses that's called name A, and it calls itself again over and over. This is called a recursive method call. So basically you are using the same method implementing itself. Okay? So for example, in English words it's not usually helpful. However, in programming, using a recursive definition is usually very helpful. But before applying this recursion methodology, you need to understand the problem, and if the problem is amenable to such kind of, or if it is implementable in such kind of methodology, is also an important fact. So you have to, think recursively and understand the recursive definition before going to try to implement it. So let's say you have a list of numbers such as this one, 24, 88, 40, and 37, and then you can define this as a recursive manner such that a list is a number, either a number or a number comma list. Okay? So in recursive thinking, this is called as the base case, and then this is called as the recursive case. So in the base case, you need to, if you continue recursively forever, how are you going to stop it, right? If you call itself with A, and over, what's going to happen is that this is going to go like a loop goes for infinitely. This is going to call itself over and over. So you need to have a stopping condition, which is the base case. In this case, the base case is having a list that is composed of one number. And then a list can also be, to extend it recursively, you need to have a common case with calling itself, in which case this is the recursive step, number comma list, so that you can transform this into a recursive list of numbers. How can you do that? If you look into this example again, as you see, you have number comma list, and then you have again a number comma list, and then number comma list, and at the end this is considered to be a number, and this is where you stop. Okay, so this is kind of gives you the intuition or the idea behind recursive thinking. And if you want to write, for example, one of the most common examples of using recursion is, can you think of any mathematical expression that resembles recursion? Factorial is one example. Anything else? Power can be also recursive. Yeah, you can say factorial, let's say n factorial, because it is n times n minus 1 factorial, right? So it's exactly matching. So you'll go all the way to the base case. Base case is what? Base case is 1, right? So you will have 1 factorial is equal to 1. That's by definition equal to 1. And then the remaining can be generated by using these two rules. And then for power, such as, let's say, 2 to the, or let's say x to the y, you can say this as, how can you express this? X times, right? X to the y minus 1, and so on. So the base case is going to be x to the 1 is going to be equal to x. And then for Fibonacci, you know the Fibonacci numbers, right? So if you have fn, it's equal to what? Fn minus 1 plus fn minus 2, right? And the base case is f0 equals to 1, and then f1 also need to be defined 1, since for f2 you need both f0 and f1 to start with. Okay, so for example, these are, basically most of the time you see the Fibonacci or the factorial examples there as your recursive, examples in implementing different things. However, we will go over different examples and different, problems as we go. So, as I said earlier, all recursive definitions must have a non-recursive part, which is the base case, which will stop the execution and which will prevent going for forever, right? So if they didn't, there would be no way to terminate the recursive. Such a definition would cause infinite recursion, and in this case, it's like a infinite loop which you would like to stop for. The non-recursive part is called the base case, as I said earlier. For example, n factorial, as we said earlier, you can express this using the base case, 1 factorial is equal to 1, and then n factorial for the general recursion. You can say n times n minus 1 factorial. So if you look into this example, you see that 5 factorial, 5 times 4 factorial, and then you have 4 times 3 and 3 times 2 and 2 times 1 factorial. So if I ask you to write a factorial method, so let's say we would like to write a public static int, and then let's say factorial, and then it takes an int n. So this is going to basically return me n factorial when I run this method. So how am I going to write the internal implementation. So basically, I will say if, I will explain the base case first, right? If n is equal to 1, I will say return 1. So that 1 factorial will return me 1 at the end whenever I call this last iteration. Else, let's say we are assuming that this always takes positive numbers, okay, no negatives. What am I going to return or indicate as a statement here? We are trying to write it recursively. Exactly. Return whatever the definition tells you. N times, you can put a parenthesis or not, and then you will say fact n minus 1. Okay? So this is exactly what you will need to do for the recursive n factorial. So whatever you see there, you see this is the last base case where you're going to stop. If n is equal to 1, you'll just return 1. Otherwise, you will multiply it. However, you're going to multiply whatever is returned by factorial n minus 1. So basically, how this is going to operate on is going to be something like this. So it's going to basically have, let's say I call this factorial 5. Right? What's going to happen? It is going to check n is equal to 1. No, it will come to the else part, and then it will say, hey, I'm going to get 4 times factorial 4. Sorry, 5 times factorial 4. And then this is going to be called again itself, factorial 4. It will check n is not equal to 1. It will come to the return part. And again, it will say, hey, this is going to be equal to 4 times factorial 3. And then it will call factorial 3 again, which will call itself. So it's going to, again, n is not equal to 1. 3 times factorial 2. This is going to be called again, not equal to 1. 2 times factorial 1. So this is the return path now. It is going to see factorial 1. Factorial 1 is going to be if n is equal to 1, return 1. So this is going to finish as a 1, return as a 1. And then this will return as 2. And then this will return as 6. And this will return as 24. And then this whole thing will return at the end as 120. So actually returns happen one after the other one immediately. Once you reach to factorial 1, you'll return back the route over to the top caller, which is factorial 5. Okay? So you should think it in this manner in order to implement any, recursive problem. So if you want to implement, let's say, Fibonacci, how are we going to implement Fibonacci? So I'd like to write, again, ignore that there's no negative values. So you need to have the necessary checks for that part, but I'm just omitting for the time being. So let's say I have public, static, and then int, let's say Fibo, and I have int n. So I'd like to find Fibonacci n. So how am I going to write this down? It's very close to the n factorial case. However, you just have to, write the corresponding mathematical formulations. So the base cases, I will list those first. If n is equal to, or I could just say in one statement, if n is greater than, or no, if n is less than or equal to 1, again assuming no negative values or 0, okay? if n is less than or equal to 1, I will return 1. This is the definition of Fibonacci. Else, what am I going to say? I will say that return I will say Fibo n minus 1 plus Fibo n minus 2. You can have parentheses or leave it, doesn't matter. So basically this is going to do the job for you for the Fibonacci sequence. So again, when I say Fibo 3, it's basically going to come to here. Since n is not less than or equal to 1, it will come to the else part. It will say Fibo 2 plus Fibo 1. And then obviously the first thing will be evaluated first, so it is going to go with the first one. So it will try to evaluate this first. Fibo 2 is equal to Fibo 1 plus Fibo 0, right? And then whenever you see Fibo 1, it will evaluate to 1. And then this one also will evaluate to 1. And this whole thing will be equal to 2. So once this is finished, it is going to go into the second term. This is important. If I had system out print lines somewhere here, it's going to change things a lot. Okay? Whichever comes first is important. So it's going to then start this second component in Fibo 1, which is going to basically return 1, right? So that this whole thing is going to return you as a result as 3. Okay? So you will first finish the first branch, and then you will continue with the other part of the recursion tree. So this is basically, this can generate a recursion tree. Basically what you have here is that, let's say I called Fibo 5. The operation is going to behave something like this. So you will have Fibo 4 and then Fibo 3. And here you will have Fibo 3 and Fibo 2. And then you will have Fibo 2 and Fibo 1. And this one will have Fibo 1 and Fibo 0, right? And then here you will have Fibo 1 and Fibo 0. So basically what's going to happen is that it will evaluate this, try to evaluate this one first. And then it will try to evaluate the first component of this first, which is this. So it will come all the way to the left most element of the tree, then go up here and finish this, okay? And then it will come here and finish this, and then it will come here, go there, so it will finish this and then finish this, and then it will start here. So basically the traversal of this is going to be something like this, and then it will go here, and it will go here, and then it will go here, here and there. It will come back to this point. To continue with the right hand side, it will do the same thing. So you will have Fibo 2 and Fibo 1, right? And here Fibo 1 and Fibo 0, as you can imagine. So it will do the same thing. Once it is finished with here, it will come all the way to here, there, and then it will return back to the top of the tree. Okay? So anything, you know, that could be implemented using itself is called recursion. So we will see other examples of recursion and try to write the code for specific things as well. So let's give a break and then we will continue afterwards.